So, hello and welcome to the third lecture on probability theory, where we are going to compute the probability of a particular event, part 2. So, in the previous lecture, we actually worked out the probability of the random experiment of the coin flip 2 times in a row. So, in this lecture, we are going to focus on a different random experiment, namely the one of the roll of a die 2 times in a row. So as a random experiment, we have the roll of the die two times in a row. So this time, when rolling the die 2 times in a row, we obtain a different sample space, of course, and this time the sample space contains not only 4 different elements, but 36 different elements. So sample space of this particular random experiment so basically the sample space has 36 elements. Let's call the sample space S. Basically, we could have, when we roll the die, the outcomes 1, 1, 1, 2. So first roll 1, second roll 2. Then third element would be 1, 3, 1, 4, 1, 5. Up to 1, 6. And then, of course, as first outcome, we could have not 1, but 2. So we repeat the same procedure, 2, 1. Second roll would then be a 1. Then we could have like 2, 2. Then first roll 2 again, and second one 3. And then as next element we could have then 2 again first, and then 4 a second roll, or 2, 5, and 2, 6. So basically we can repeat then this for 3, 3, 1, etc. up to 3, 6 again. The same thing we can actually have for 4 and for 5. So I put here 3 dots and just only put on the last row, which would then basically be like having first a 6 and then a 1, 6, 2, 6, 3, 6, 4, 6, 5, and the 36th and last element of this sample space would actually be then 6, 6. So basically here we have also 3 dots, and here we have 3 dots, meaning that we have additional elements that are not presented here, but that are very similar to the one that are presented here. This very heavy notation can actually be put in a more concise mathematical advanced notation. So let's call it concise notation. Basically, we would have the same sample space, so S, and then the set, composed of elements, of course. Let's call them I and J, subset closed. And we have like I and J running from 1 to 6. So for all I and J belonging to the set 1, 2, 3, 4, 5, 6. So that would basically be more concise notation. The aim here is not to focus too much on this notation. If you want to have more explanations on this precise notation, please leave a message in the comment section below, and I will produce a separate video on this particular topic. So as events here, we could actually ask, for instance, what is the event of obtaining 2 times the same element? Like, for instance, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. So that would actually be then a particular event So let's call this particular event let's call it A. Put A here. So it's basically composed out of 6 different elements. So going from 1, 1 to 2, 2, 3, 3, 4, 4, 5, 5, and the last one, 6, 6. Another particular event that we could actually be interested in is to obtain only 2 times 6. So basically this one here. So let's call this particular event B. And it will have only one element, namely 6, 6. So as announced in the title of this lecture, we would like to work out the probability, the corresponding probabilities of the events A and B. So let's put in here the probabilities. So probability of obtaining A, the event A, would then actually be probability of A. And again, here, as like in the previous lecture, it will boil down to a simple computational problem, so counting problem. So basically, we have the number of elements that belong to the event A. So basically, number of elements, we use this notation, number divided by the number of elements of the total sample space, S. So basically here we see that we have 6 different elements, 1, 2, 3, 4, 5, 6. So we put on here a 6, and we already saw that the total sample space of this particular random experiment has 36 different elements. So 1, 2, 3 up to 36. So then we put in here 36, and by simplifying we obtain 1/6. So that's basically the probability of obtaining 2 times the same number when rolling a die 2 times in a row. So as last question of this lecture, we would like to answer the question, what is the probability of obtaining 2 times 6? So obtaining 2 times 6, basically we put the probability in here. And the probability basically is, again, it boils down to a counting problem. So we have probability of, we have the number of elements contained within the event B divided by the total number of elements contained within the sample space. And basically here we have like only one element in B. And again, the total sample space had 36 different elements. So basically we divide 1 by 36. And that's then actually the probability of obtaining 2 times 6 when rolling a die 2 times in a row. So with this, basically, this concludes the 3rd lecture. Looking forward to seeing you again in the next lecture, where we are going to compute the probability of the total sample space.